Okay, just a quick follow-up to what I just showed you. Actually, I just showed you our little helix, and this is actually the vector equation of the helix. And you'll see this. This is a pretty common one. They usually start everyone out with this one. It's kind of like the x squared of the vector world. So pretty common. So basically, you know, like if t were to equal 0, we'd have what? We'd have 1, 0, 0, right? You know, so we'd have a unit vector basically of x. If it were equal to pi over 2, we'd have 0, 1, pi over 2. You know, so it's just kind of numerically, if you think about it, the magnitude, the direction change, etc. Okay, so basically, now we have all our components. Now of vectors. You know, before, we've been working with our vectors, kind of reviewing stuff, and all the vectors were pretty much just, they were in these brackets like that, and you'd have an actual number in there, okay, and they'd represent, a constant vector, okay. Well, now what we've done is we've introduced the components of vectors to be functions themselves, okay. So the x component changes with respect to t, and at the same time, g changes with respect to t, and h of t, and etc., etc. So, that's kind of basically, it's going to be used to do a whole bunch of things, if you can imagine. So, and it's actually, they're actually pretty easy to work with, there's some complicated stuff, but once you get the hang of it, all that stuff that I've been talking about before, like dot products, cross products, all the lines in space, once you get the hang of working out that stuff, this stuff isn't too bad. Okay, so let's take the limit of r of t as t goes to pi over 4. Why not? Of r of t. Okay, well, if we do that, basically we just take the limit of each part. So cosine, that's just square root of 2 over 2, square root of 2 over 2, and then t, that'll just be pi over 4 again. All right, just like that. So basically, the closer that t gets to pi over 4, we start to approach this vector right here. Okay, so we would go, we'd go out, 0.7 over 0.7. We'd go up, pi divided by 4. I don't know, get, something like that. So it's about 0.75 ish in there, somewhere around there. So that's just basic, and this is a quick video, so nothing too elaborate here. This is just an introduction to the vector function, and you're just gonna have to be able to visualize these pretty good, because they're kind of hard to sketch, and they're even harder to attain a graphing calculator that'll handle them. So, all right, next video, please.